So as we've got in here, colors are good. So if you need some, again, they're up here towards the front. Calculator as well, and here's why that's the case. And again, notice up here with our direction, we are going to skip number 2. In retrospect, I started keying this, and I'm like, woo, that answer is really, really big, and we're not going to be able to fit that on a graph. So that's not going to work out so well. So we're going to solve each equation by graphing each, finding the intersection. Isolate your radical if that is something you need to do. So we're going to take a look at a couple of these, like we do typically on most days. Thank you and thank you. So we're going to jump down here to number 6. So the first thing I notice when I get down to number 6 is my radical is not isolated. It's not on a side all by itself. And we want to fix that first. So we'll go ahead, we'll get the 1 out of there. Okay, so that'll help our situation a little. Once we get here, this is where when I was talking about just a little while ago, that sometimes it may be more difficult for us to just use our base or something. I have a whole lot of stuff going on in here under this radical. So probably me trying to do a base and shift it and what do I multiply by is probably going to be more trouble than it's worth. So what we're going to do instead, and why you've got your graph paper today, is basically we're going to type these into the calculator and let the calculator help us out some. So let me get this up. We're going to get to our y equals here. If there is anything in any of your y equals, hit clear to get those out of there. And we're going to get these typed in. So again, when you are graphing, let's see if I can avoid the glare and do this still. Ooh, I can. Okay. We are going to take a look at second and x squared. That's going to get me my radical. And then I can type what's underneath. And then I would go over to my second, which is just 3. Okay, so 2 lines. Each side of the equals gets its own line when we're working on these. Once I get there, let's take a look at the picture first and see if we can see an intersection at all. And then we'll kind of go from there. So I take a look and I notice, okay, looks like right about there is where they're going to cross. So there's a couple of ways I can get my answer here, but we're also going to have the graph paper if we want to take a peek at it. So if I hit second graph to get my charts up, okay, y1 is my values from this, my square root of 3n minus 12. My second column is pretty easy to tell. It's all 3's. So we talked a little bit yesterday. If I start to scroll down, what I'm looking for is a place where the y values are the same. Once I find that, that's not my answer. The x value there is. And if I wanted to do this more visually, which is the reason I've got the graph paper working here for us, I'm going to try and do a quick slide here. I don't know if this is going to work, but we'll try. Not too bad. Is that I could go ahead and make myself a quick sketch. And I don't care. If they're out of order a little bit, we've had worse things happen than that. So for my radical part, my square root of 3n minus 12, what I'd do is I'd go through looking for the whole number part. So like here, I'd have a point at 4, 0. Scooch this a little more with how far I zoomed in. At 7, 3. And I might be able to squeeze one more. No, maybe not. So you're like, dang, you've only got 2 points. Okay, well, let's lightly put our line through there. And then I know with my second one, when it says y equals 3, it just means I go up to 3 on my y-axis. And I draw a line across. And so again, that gives me the opportunity to see where they intersect. And again, it's the x value of that point that I want. So I'm like, okay, 1, 2, 3, 4, 5, 6, 7. And I can see where this comes from. So today the graph paper was given to you more to see, hey, you know, visually, do you want to see what it is? You can just use the calculator, and if you can find that point where the y values are the same and write down the x, that's fine. I'm okay with that. Okay, but I want you to get that practice so you can see it that way. But we also want to be able to do the graphing part as well. The other one I want to take a peek at with you is number 10. Now this time my radical's on a side by itself. I can't do anything else because that's all underneath. So here, I'm going to pull the calculator back out. We're going to clear those out. Second and x squared to get my radical. Type what's underneath. And then the second line is just going to be x. Again, we'll take a peek here. Now this is kind of interesting because it looks like anywhere in here could be where they're crossing. So let's take a look at the chart here. So I start looking and I'm like, oh, okay, well there's my y's are the same. So x equals 2. But then I go down and I'm like, well, wait a minute. The y's are the same here as well. Okay, so it looks like I've got 2 answers. But let's kind of look at this with my graph paper again here and see what exactly is it. You know, is something flukish going on, or is that actually the case? So, let's see, best way to do. Get my axes drawn in here. So again, with my first one, okay, I'm going to cover up my 10, but we'll get the point here in a second. So for my square root on the left, again, I'm using these y1 numbers with my x's. So like I've got a point at 2, 2. I've got a point at 3, 3. Am I going to get any more in here? 11, 7. Now let's see if I can fit this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. So I can kind of sketch that one in. And then for my y equals just x, remember, y equals x just really means y equals x plus 0. So I'd have my first point at 0, 0. And then it would just keep going up 1 and over 1. Up 1 and over 1. Up 1 and over 1. And I'm seeing those points. So that's why when I was looking at the calculator before, it looked like it was crossing in several places because it was close in some, but it was right on at 2 and at 3, just like we found when we did it with the chart. So again, the chart's y values are the same. Those are your answers, okay, those x values. And like I said, I did it on this one today because I wanted you to kind of push towards the calculator. If you want to see it visually, graphing them's fine, but if you see those values on there and you want to just stick with that, I'm okay with that too. The one other one I want to do with you is on the back. Like I said, I'd noticed as we've been going through some of this, our regular graphing has been suffering a little bit. We'll put it that way. And so we're going to take a look at number 2 and number 3 here, just to kind of give us a reminder of how all this works. So when we're graphing a regular line, I'm always going to look to see if there's a y-intercept first. If there isn't one, I count it as 0. So like for instance on number 2, this is my y-intercept. And that first point's going to go somewhere, in this case up at 3 on my y-axis. then whatever number's in front of x is my rise over run, my slope. If you just see in this case a negative, it means it's going to be negative 1 over 1. If there's no number there, it's just 1 over 1. So rise of negative means I'm going down. Run that's positive means I'm going right. So down and right, down and right, down and right. And if I run out of room going one way, I just do the opposite of both. So instead of down and right, I go up and left. Up and left, up and left, and connect my dots. Okay, that's just a plain old linear function. Makes a line. Then it's more into what we've been in lately. Okay, sketch the graph of the function. Now again, could I go straight to a calculator on this? Sure, and I'll even show you that in a second. But what we've been doing, and what I think benefits you more greatly with this, is looking at this and going, okay, I notice there's two shifts going on here. Inside the radical is always my left and right, but it's the opposite of what I would think. So we're going right 1, and then anything outside the radical is my up and down shifts. And again, you've got this on reviews. You've got this on notes. If you need to go back and look at some of those, that's okay. So right 1 and down 2. But from what points am I going to be doing that? I'm going to graph my mother graph, but I notice there's a number in front this time, and I slipped back, my parent graph. So normally when we're graphing a square root function, when we're graphing its parent graph, we use our perfect square x values, and again, I can't encourage you enough. If you know those, it makes this so much easier. And then y is just the square root of each of those numbers. But those aren't my parent points for this one. For this one, my parent points, since I have a number in front, I have a coefficient, I've got to multiply all my y values by 4. Okay, note the y values by 4. So my x values stay the same, but my y values for my parent points will change. So I'm going to plot those little. I'm not going to make them huge. Can't even fit them all on the paper this time. That's okay. So I'll get the 3 on there that I can. But then to finish the problem, because what I plotted there is only this part. Whoops, don't lose my x. Now I'm going to take those points and I'm going to shift them right 1 and down 2. Right 1 and down 2. And down 2. And I only want to connect the dots on the one that I'm using as my answer. And that's it. So today is more of your opportunity to practice with these in the calculator. Look for the y values and make the connections. Practice some with your graphing. And if you need to, go back and finish up some of the ones from yesterday, or maybe, just maybe, go back and look at some of the things from the last quiz and start cleaning some of that stuff up with some in-class time that you get there. Moving ahead, we'll be looking at circles starting tomorrow, and then we'll start working towards the end of the unit. So keep up with this, check answers, ask questions.